Judy Warner. Welcome back to this week's Ecosystem Podcast. Today, my old dear friend Eli Hughes and I get to riff a bit about engineering, and I've always appreciated what he calls his role as a full-stack hardware engineer. We're going to talk about his time as a professor at Penn State and the different transitions he's had over his career and how he's taken advantage of the NXP Freedom Developer Platform. We're going to geek out a little bit in this podcast, but I think you'll really enjoy learning about how he's leveraged this platform to do many things across his career. Now let's jump into our conversation with Eli Hughes of Wave Number. Hi, Eli. Thanks so much for joining us today. It's been a while since we've done a podcast, my friend, but you are always one of my favorites and you always teach me a lot. So thanks for joining and telling our engineers a little bit more about what you're doing these days.
Well, I'm happy to be back and talk anytime. I say I always talk for free. So
Well, and you and I can talk, no problem talking between the two of us. And like I said, that's where I always learn so much from you. So why don't you take a moment and just introduce yourself and tell us a little bit about what you're doing at Wave Number and also the work you're doing for NXP.
sure. So my name is Eli Hughes. I live in State College, Pennsylvania. It's the home of Penn State University. I actually moved here over 20 years ago for grad school to get a graduate degree in the science of sound. I came from an electronics background, but kind of blended that to kind of branch into a more interdisciplinary type career. So yeah, so Wave Number is just my company. We have a small cohort of highly capable people that, our mission, it's not actually a technical one. I tell people it's like three things. We create, we communicate, and we serve other people in other businesses. And those are the three things. We just happen to do a lot of neat engineering along the way. For in kind of along the way, part of the kind of service and all three of those: create, communicate, and serve for NXP. I've been working directly with NXP before it was just NXP, before it was Freescale and NXP, and even before that when it was Motorola and Philips Semiconductor. So but just over the years, just starting with I taught with Motorola products, Freescale products, and NXP at Penn State University, and it kind of also grew into the engineering side of the business side. So that's kind of a little bit about what I do.
So why was that brand and that company so sticky for you? And how did you particularly use that as an instructor at Penn State and then take this into your professional engineering life?
Uh, it's there's always like an origin story, and usually it starts. We always think about like a technical piece, but there's like a human piece that starts. And I had like a relationship with my undergraduate advisor. He worked for Digital Equipment Corp. He worked on some of the original, DEC Alpha processors, and he was an interesting fellow, very tough, but I learned a ton. But that was one of my first experience with microcontrollers, where he taught with a Motorola HC11, and so Motorola is what became Freescale. Freescale is and kind of what became NXP. Um, and so it started for me just, that's what I learned in college. But, when I kind of moved on and was teaching, it was natural. I was using a lot of the products just in my engineering life, but kind of bringing that to students, it made a lot of sense, as well as just, the tooling was there, and it was different too. That when I went to, so I was in uh university in the mid 90s, so like mid late 90s. So getting development tools for like professional tools was not inexpensive. The universities needed industry to donate like the boards we used for like $500. They were locked away. Like the real
Right.
change was the like students could now have like access. I mean, I always told students this. I said, you have for $15 a chip that took the sum of human civilization in material science, engineering, business to create that, so you have it. Like, wow. Like, so, but it changed teaching a lot because instead of going to like the tool room and you borrow the thing, I made students buy the dev kits like in lieu of a book because they took care of it because they owned it. But then we could do a lot of neat things. So yeah, that's kind of where it started and
Hmm.
where, for example, like the Freedom platform was a really big deal. When it was first released because of the low cost nature and just the availability.
So one of the things that you coined a phrase or a title, I would say, that I always think of when I think of you, and I've quoted you and used it many times again, which is a full stack hardware engineer. We usually think of full stack engineers being in the software disciplines, but you really talked about thinking sort of across the systems and collaborating, having insight. And I imagine the way you were teaching your students at the time, you were also giving them tools that were affordable that could allow them to do not only university levels, but help sort of shape their thinking as they went into the working world. So, what were tell us a little bit. You mentioned the Freedom Development Boards. Tell us why that board and I know you've carried into your professional life because I've heard you talk about it before. So tell us a little bit about that because that's going to be the core of our conversation today. And I'm interested to learning from you.
Yeah, this once again, I go back to some of those like foundational experiences of like there was definitely some like I was a total I, I was not useful in high school. Like I nearly didn't graduate. I just lost interest in anything. But like when I kind of discovered electronics that you could build things, but not only just it wasn't the electronics, it's that I could take a chip for one purpose. And one of those purpose I like were video games and say the Nintendo, but reconfigured a little bit and it could have a completely different purpose. And a lot of times it wasn't about the chip, it was what it connected to in all those applications. Well, to play in that, you've got to be more than just the hardware person or the software person.
Right.
And, so for me, especially with my advisor, he was where I learned digital signal processing. And like part of my love of like, see like guitars and audio came
Uh-huh.
from the technology development at the time and even through now of how were they building all this hardware. So it tied in acoustics, science of sound, and it just went down this big rabbit hole for me that I knew that I can't just be a hardware person. Like, you have to write code, you have to understand mechanical engineer, you have to know some business, you have to have some people skills to build things. And but no, in the classroom, so I really strived to because I at like at Penn State, I taught fundamental circuits, but circuit theory with like transistors and diodes, but I also did FPGA course as well as microcontrollers. But in the hands-on course, in every one of them, we had tests and whatnot, but I focused more on projects where if like
Right.
the microcontroller course, the midterm was a project proposal of what you're going to build for your final. And your final was this project. And there was some testing aspects, but we we got to do some more interesting things. And one year we did a special focus on like audio engineering. And so I recognized that there was a pretty big chasm. There are always students interested, but when they graduate, for those first few years, those getting those 5 years experience that unemployed
Right.
for, there's still a gap that I saw where students would learn things in university, and there's just a lot of these connecting pieces that were not connected, that were just at another level, and so I'd actually worked with it was Freescale before NXP, to fund some projects where they were that's the origin of like I use this monkey character in all my projects now, and that was
Oh,
the
yeah.
origin because I had 3 projects. I had Monkey Jam was for a guitar, Monkey Listen for a microphone, and I think it was called Monkey Do was like an IoT project. But the idea was to have some videos, courseware, projects that weren't targeting absolute beginners or mid college, but this in between where you need to go from I'm like the Jedi Padawan, but how do I get to Jedi? Like, there's like enough, like that next level. And so, like, yeah, one of the first things I did was like with the early Freedom boards was Monkey Jam. It was to learn about digital audio interfacing, but also the digital signal processing, the math. But you could buy at the time, this board was $10. And then we made the little open source shield that goes on top. The total cost was another $10. But you could then just take things to another level, and that's what Freedom was originally great for. It just made it accessible because it wasn't like you're gonna invest thousands. It was a little bit of money to get started. So,
What I love about the way you're teaching is because there's always this conversation about universities coming out of university have a lot of theory, but they don't have enough hands-on. They haven't, they get a what's it called, capstone project that is usually pretty simple. And the ones that I see do really well are in engineering teams. Why? Because they're touching and building things. And I think with you and your program, you help them connect the dots from all the theory in the classes that they take to actually making something work. I think that's really powerful learning that you served up. So as you're talking about this development platform, Freedom, like what's the difference between you said NXP likes to do provide some open source development tools, and that's what Freedom is. What's the difference between that and say something like Arduino?
that's actually a good question, and, like, I would actually get that through, w not only when I taught, but just, interacting with other, like, makers or, like, pro makers of. So Arduino is a brand name, like, and it was a great thing where they were trying to do the same thing of just make it super simple to kind of light the spark. So it was
Yeah.
a combination of a couple things. It was like a software platform, the right code, but it was also a piece of like a branded piece of hardware with like a pinout that you could plug. They call them shields. So but at the end of the day, at the time, the first one was like an Atmel part. It's fundamentally I tried it when I taught, I said, "Okay, even if you use Arduino, that is a microcontroller with a part number. Once you unlock the tools to write code for this and understand how it works, you can you don't have to buy one brand, you can buy any brand because you know the tools. So you can and so the Freedom board is just very similar. Start as like a hardware form factor. You can plug the same type of like shields in. It was just NXP's kind of flavor on it for their chipsets. But the and actually you could use
Which
and
are powerful chipsets, by the way.
oh
These are
god, yeah.
not so,
We're going
I
to talk
mean,
about that in a second. But
okay.
so it's I'll say it's another interesting term. It's the same but different. So it's
Okay, and of
kind of the
course,
thing.
now you've queued me up to say, so what's the difference? We just touched on powerful microcontrollers. What what are the differences that you see? And again, Eli, you've been doing this for a long time across multiple hats you've worn as professor. You had a startup when we first met, and your engineering firm now, and all the things you've done. It seems like this has been sticky for you. So, what is the difference? You're not an Arduino guy. You're a Freedom guy. Why and why? And share that with our listeners. Maybe it's something that they would like to learn more about and engage with.
Well, in some of it, it's like, all right, like to avoid like a Coke versus Pepsi argument, like, but
Right.
I kind of go back to the fundamentals. I look at everything, not necessarily in terms of the brand, but the chips that are on it. Like when we debug, like I say that you go to the schematic. Like that's ground truth, right? Go to ground truth and just
Right.
it stuck for me mostly because in some of it's like nostalgia. I think back to my advisor and we had this kind of Jedi Padawan relationship and I kind of was brought up on Motorola. So there's some kind of heartstrings pulling there.
Right.
Um, and, you know, for a lot of people, that is what happens, right? And you get used to an architecture, but at the same time, you learn the skills. So you're kind of like multilingual. It doesn't really matter because you're still writing C code. You can even open the Arduino environment and program NXP chips in it. So it's like once you learn how to separate the pieces, you learn how to kind of like use all these different things. It just happened that I think with NXP, it was the broad selection of boards you could. So they made Freedom boards for almost all their microcontroller platforms. So it's not just one. That, while it for a beginner is a little more challenging, it bridges in the professional space where maybe you want to buy, and I've literally done this, right? A prototype, we needed 30 of something just to cobble together at 20 bucks a piece, 600 bucks. You go to DigiKey, you get it. I mean, it's instant and it's a development board for that chip and it's a full professional development board. And one difference that I think is key to point out, and it's big for me, is that NXP builds in um, a debugger on the board. So it's very, so
Mm,
for a student, it's just like using a J-Link they'd use in like in the professional space. And that's like another level of people who learn how to do like in-circuit debugging, because the debugging tools from people like Seger are just have gotten phenomenal. And NXP has been big about that board, kind of covers both the professional use case, the hobby use case, the academic use case, and has all the stuff in it. And you get just a selection of different, and it's not incompatible. You can like take boards from this other brand and plug them in and make it all work. So, that's a big deal to me.
so it sounds like there's one, lots of flexibility, lots of power under the hood, and flexibility that you can tap into, and it still plays well with others, which is lovely.
Yeah, and that's
Um,
I think too, and like NXP's been it's been interesting just watching different. There's been a lot of consolidation in semiconductor industry over the last 10, 15 years of this chip company. Like it's hard to
mhm,
follow actually, but like,
truly.
one trajectory that, there are certainly people who are leading on it. And I personally feel NXP is on the open source side of their SDKs. Almost everything is in GitHub. It's like as open as you want it to be, not only for microcontrollers, all the way up to their chips that power. They just released the Freedom Item X93, which is in a totally different space. It's in the applications processor space, like kind of like a Raspberry Pi, but it's truly open source the whole way. Where, I mean, there are NXP engineers and pushing code into the Git kernel, right? It's a big deal, and it's not a whole lot of people know about it, but probably should. That everything from Python tooling they have for their security systems to just, the SDKs, it's all in GitHub. And they've really been, I think, a pioneer there, in which I think everybody benefits from that because you get a lot of
Yeah,
choice in
yeah,
how you
and
want to
as
approach
we
it.
know, engineers love a lot of choice. They're very particular about the tools and things they wanna do.
Oh,
So
very
what
particular. Yeah.
very particular. Y'all are pretty particular, I've
Yeah.
noticed. So I can see why that kind of flexibility and open source would be huge, which just tells me they're listening to their customer and paying attention. And ultimately that goodwill and that availability is gonna pay off ultimately with buying more of their chips and doing more with their tools. So I think it's a smart strategy. So I know you've used this, like I said, across multiple experiences in your life as an engineer. So what what kind of applications are well suited, or give me some use cases, maybe stuff you've done. You showed a few
Sure.
things there, but like give us a feel for applications.
Yeah, so a lot of what I do does lean towards like this acoustics, vibration, audio. It's because it's a passion as well as other things, but it's growing into a lot of other things. And well, one before we leave the discuss, like I wanted to into like some more of the professional, like in the academic, I like a little story. Like this was their one of their latest boards, the Freedom MCX N947. It's interesting because for $25, this thing, it's a dual core processor with a neural processing unit inside for AI for 25
Wow,
bucks and has
that's
Ethernet and
crazy.
connectivity. So we used it. I built this little motor control shield that we took to Guatemala last year for a
Well, that's
university
fun.
event to
For listeners, it looks like a little rocket with
oh, yeah,
8
I called it
pins
the
on
rocket
it,
board.
and,
Yeah,
yeah, it totally looks
has a
like a
little
rocket, and
flame
the other
coming out
thing
the
looks
bottom.
like a electric scooter, so that's
So
fun.
we had a little, racing competition, autonomous car competition where you have a camera, this little car, and you put the board on it, and you could kinda see the camera on the screen, and basically writing algorithms to control the car. And we kind of kicked it off again and rebooted last year with the N947, mostly because it had like the digital camera interface and all this memory and the NPU for doing like object detection. And it was like the fact that the board was 25 bucks. We designed and built, Wave Number actually built the little shield that went on it to plug everything in. And with the students had like this fundamentally awesome experience that, and they got to touch professional tools along the way. Like we went into the compilers, the debuggers, and vision systems, and it was like a week boot camp. And like it's nice just having some tools that what they learned there, if I want to hire them, like they're ready.
Right.
Which I did. Which one of my employees lives in Guatemala, Jerry. He was a former student there, and just holy crap, is he smart. And like the fact that he
I
can have
mean,
access to these tools
that
is awesome.
piece right there makes me a fan of freedom right off the bat and what you're doing because again, the disconnect between when you graduate and engineering managers, I've heard talks about the ramp to productivity, because they hire you, they pay you good money, and they want the shortest ramp to productivity.
Yeah.
Well, Eli, using the Freedom platform and doing these things like your boot camp, you shorten that ramp or you've made them be able to be more productive and have more professional like skills going in. And companies are desperately looking for that. So I would think that engineers, even if they put that on a resume, that they've done that would possibly make them stand out as they go into the professional space.
And I always told students, work on projects, like
Yes,
control the
me
interview,
too.
right? If you can show up like with your thing you built and be able to talk about it and
Yes,
control that conversation, like I know for me, when I look to hire people, that's what I want. Like, holy crap, when
totally.
I want to find that next like high midi chlorian count Jedi Padawan who's ready. And
Right.
like they
Yes.
just need the opportunity to do it. And
Right.
um
I could talk to you about this for a long time, but I think you're helping me connect the power of using an inexpensive platform to make that transition between theory and real world and build stuff. Because when I was at Altium when we first met and I was sponsoring engineering teams, um, I know I worked closely with a few engineering teams that were building for SpaceX Hyperloop competition for quite a while. But there are two students I got really close to that were from University of Wisconsin at Madison, which is a very engineering rich school. And both those particular students were building hardware for this Hyperloop and they designed and built and did the whole thing, but they both told me later because we'd give these teams, PCB design software. They both came back to me and they got a job straight out of college, but when they went for interviews, they had a portfolio and they had physical boards and said, "I made this, and I
yeah.
ran it in the SpaceX Hyperloop pod." It's like, "You're hired."
Yeah, I mean, you just I don't need to look at
Right?
anything else. Here's
And
like I'll give you another example, and, like, this is probably, like, more on the professional side, like, bridging into that of, like so I do a lot of, like, PCB design, like, that's kinda like a passion of mine. So, a lot of, like, end consumer industrial products, but it always starts with, like, boy, on my bench, if I can get quick tools that you add to that digit key order that like, I don't wanna call it like I'm throwing it away, but it's throwaway in the sense of that it's not even a decision when you look at your value of an engineer's time per hour, dollar per hour, buy the
right.
thing. So, like, here's an example. This was like a new, Freedom board for the, MCX A156. It's a new, NXP platform. So, I actually have a client who is building a super high-end, like, audio system in the medical space, and among all the other things it has this really complicated microphone array that has to hook up, and I worked on a lot of the code. Well, it's now getting the production. Well, they have to test the thing that measures the microphones. So we have to simulate those microphones in a test fixture to get through production. Such a thing does not even exist. You could at
Right.
any price. So Jerry, who I mentioned works for me, we put this little project idea together called PDM monkey, and PDM stands for pulse digital modulation. It's a scheme used for digital microphones like in your cell phone. Well, the idea was to take this low cost NXP chip to simulate 8 microphones as if they were real microphones. So you would almost like play a wave file in this thing and it would generate the signals like it was the real microphone array. So
That's crazy.
we bought the
That's
board,
so cool.
we rigged it up, made it work. Well, as I was working on the hardware, Jerry was actually helping with the software. We used the Zephyr RTOS, and that's another open source initiative. Um, NXP is huge behind, and I'm kind of like a Zephyr like fanboy. It's another one of those things that it's a big plus up for embedded companies that if you know it, it's a quick ramp to building software and teams. So Jerry was working on some of that firmware. I was working on the hardware, and we made a real board for the actual production test fixture. But it started with the little $15 Freedom board. I could ship him 8 of these things, so it doesn't even matter. Like,
Right.
and he could be working ahead. And like I said, I'll use that term throwaway in the sense that we can get it. It's not. It removes a decision that before the decision, say 20 years ago, do we buy? How many of the $500 evaluation kits do we buy? Now
Right.
it's how many are we limited to? Like, how many are in stock? Let's buy them all. I want a shelf full of them. That should never
Right.
um to keep developers working. And
What an awesome tool to have in your toolbox just all the time,
oh yeah,
right?
and you're looking at the nice side of the room. The other side where I have piles of like dev boards. I have this thing that everyone should have. I call it the bone pile. Like, it's the leftover experiments, maybe things that are half broken, but it's stuff you dig through. You're like, hey, we built that thing last year for that project. We need to like repurpose it and then add it to the stuff we just got from DigiKey. And it's like, everyone needs that bone pile. And it's easy to add to it because I think low cost dev tools and the open source, the software piece is huge because the other thing maybe younger engineers don't appreciate now is, let's say you do get, there's multiple paths to writing code for these boards, but NXP has like a VS Code plugin. They have MCU Expresso that you just download for free. When I started, if you got the whatever the latest and greatest whiz bang board, you spend 500 for the EVK. They said, oh, the software license is $5,000 for a developer.
Whoa.
Because, all right, like in 1998, there were open source compilers, but for microcontrollers, it was all very custom tooling. It wasn't like as, ubiquitous that the fact you get this software stack, like, with these tools that, holy crap, is it?
It's good for us old people to tell these kids how
Yeah.
good they have it.
But no, it just speaks to like, I'm so happy to see when people come into it that like, wow, that they have these tools that they can go further than I can, right? Because
Right.
I had to spend, a long time because cost was a barrier or just availability. And now the barrier is so tiny, right?
So,
Comparatively.
do I hear you right then that you're saying, sure, it's good for students and hobbyists and all of that, but it has major applications in the professional space as well to do these inexpensive, proof of concept or test boards or whatever it is? It sounds like it's equally applicable in both.
Oh yeah. Because one thing
That's interesting.
I'm a big proponent of is when it used to take a long time to make custom everything took a long time. Now things are quick to like prototype. Is I don't need to know a complete answer, but how can I quickly get to knowing what questions to ask, right? And how do I start in just being able to like almost any project, as soon as I have a general idea of what microprocessor we're going to select, bam, those boards are here like in no time and we start making little prototypes and I'm automatically thinking about the real circuit board while those things are flowing in. That it's not like a 6-month decision. It's like today, like this is coming, you'll be starting tomorrow and like we're up and running. And there's just so much that you can, uh, you know, on these different platforms that you
Yeah,
you
they
can move really
remove
quick.
the barrier to entry, right? It's easy, affordable, you can do it quick, and of course, besides being very particular, you engineering people, you want things quick.
Well,
And,
I think for me,
you need them quick actually to get stuff done.
for me, and it was another professor I was in grad school, is that it was more about accepting the idea of failure as like your biggest, teacher and your biggest asset because have when you're doing like R&D, the idea is you want to get to your problems as quick as possible to know where your problems are at. Like, and just
Fail
being able to
fast,
like,
baby.
boy, figure out what are your problems going to be so it's not a theoretical anymore as quickly as possible because it might not be anything that you've thought of yet. So if we can remove some of that time, you know, it's a big deal. So
It's a big deal. Well, this has been a fascinating. I've learned more about the story behind your full stack engineering thing that we sort of riffed on for a while. We worked together at Altium, and this has really helped me understand. And I've seen you post not only about the freedom, I've seen you post about Zephyr. So thanks for this conversation. I think it'll be really interesting to people in our audience, right? That want to leverage these tools. And it's been helpful to see how that's come to bear across all the roles you've had in your career, Eli. Thank you so much for doing this.
you're welcome. And it's always great to talk. So
I don't know if you have it offhand. If you don't, I'll go find it. But um, do you know where we can find more information about the Freedom platform? I think I have some that NXP sent me. If you don't, I'll put it in the show notes.
like if you just actually just type, because sometimes I just do this, I just type in like FRDM in Google and then it comes to the main landing page. Uh,
Oh
it
yeah, by the way, Freedom is a nickname. It is FRDM, but they call it Freedom.
Yes,
So that's a good tip for our listeners. But I will. I'll go I think our friend Bridget sent me over lots of links and things. So I'll make sure I get that. If I'm missing anything, I'll give you a holler. But thanks for sharing, and it's always great to hear from you and learn how you think as an engineer. And I always know it's super helpful to other engineers to learn and learn from your wisdom.
or my mistakes, yeah, so but
Same thing,
yeah, there's
right?
a green
So,
landing page I'm looking at right now that kinda has the array of all of them that are available, and you kind of pick based upon, capabilities, feature, cost, all the
right.
above.
Okay, well, for our listeners, I promise I'll get that to you, plus any other applicable links. If you have time and if you're listening to this on audio, go look on the YouTube channel because Eli's projects he shows are pretty cool. I think you'd get a kick out of them. And like I said, we'll put those resources for you in the show notes. Eli, thanks again. I look forward to talking again later this year, hopefully. To our audience, thanks for joining us. We'll see you next time. Until then, remember to always stay connected to the ecosystem.